So 64 in total. It's quite a few. But we'll let this set up. Looks like it's sitting nice and tight in this one. When I put it on this one here, it was sitting in there a little bit loose. I need it to be, 100%. Alright, we're working on this again. I was able to put together some of the forms that we're going to need for StarFlow 3. This is what they look like when we get coil wound on them, but I have to actually take this one apart because I didn't put enough epoxy on it and this side kind of broke out on me. So I made sure I put lots of epoxy on these this time, and we'll let them set up. This starts out from a single piece of steel, and then put some tape on it to protect the wires, and then cut out some sides for to hold the coil. Alright, so I got all these coils here covered with synthite. That should at least keep it's what we call potting a coil in guitar talk, but pretty much the same thing. You said we're using synthite instead of wax, but it'll still work. Alright, we're working on the StarFlow design here. We have to get all these wires hooked up to this commutator. So it's going to take me a while to get this all sorted out. We got quite a few here to go, so I'll get them all sorted out, lined up, soldered. It'll probably take me the rest of today and maybe tomorrow to get this done. And just kind of wanted to show you Command Central. So when I do my research, I have my 3 22-inch screens, and I can open up as many windows as I need. Anyways, I will continue wiring this up and hopefully get it done before too long. So here it is, it's all wired up. We got both sides done, and I'll try to mount it into the frame tomorrow, and we can get it wired up pretty quick. That'd be really good. Test it out, see if it's gonna work. Okay, this is StarFlow 3. This is what I've been working on pretty much every chance I can get. It's really coming together good. I still have to put the brushes on it. I mean, I measured all of these coils. I tried to get them to be all the same ohms, so it should be pretty close enough for what we need anyways. Proof of concept. I was able to install this pulley system and the drive motor. I also hooked it up to our DC power supply, so I'm just going to turn it on and we'll see how it goes here. I already gave it a quick test. It seems to be doing alright, so we'll turn it on. We're at 6 volts, it's building up. It's about 9.3 amps. It seems to stay around 9.39 amps, somewhere in there. It's coming up pretty close here to 10. It'll build up to about 12.5 volts. It seems to be going pretty good. That's pretty good on 12, and we're looking at about, between 8 and 9 amps. It kind of depends where yeah, we're sitting at about 13, 9 amps, 8.5, 9 amps. That's how warm this thing's getting. It's not that bad. I thought it was going to be warmer than that, but just a blower motor, so I was checking the specs on it and it seemed to be alright. Should be able to handle running like this for a very long time. So there it is. There's our RCF. Now we just have to export it in order to be able to deliver up to 18 amps. So it should be alright. Looks like it's been stabilized right about there. I don't know what RPM that is, but it's clipping along pretty good. Should give us the RCF that we need. Wow, that actually worked better than I thought it was gonna. So, very good indeed. That was a good test. Okay, so I put a bigger pulley on this, and it reduces the load off of this motor by about 25%. We went from a 9-inch pulley to a 12-inch pulley, and the RPM seemed to be looking pretty good. I was also concerned about our brushes wearing out prematurely by spinning it so fast as it was with the 9-inch. I'm not sure what RPM it is, but she's doing pretty good. We'll have to calculate that later. And so it's tracking alright, so that's alright. And we're sitting around 12 volts and around 8 amps, which isn't too bad. It seems to be a lot more stable. The voltage, the voltage off of our DC power supply seems to be a lot more stable with this load parameter on it, so I think this is probably a better way to go. Also, this drive motor was getting pretty warm before, so I'm going to run it for a bit. We'll see if reducing that load on it's going to help it run a little cooler, because we're going to need it to run for quite a while. So other than that, it seems to be going pretty good. This is about I'd say maybe 400 RPM just by looking at it, maybe 350, which is about where I wanted to be anyways. I will calculate it and go from there. So yeah, she's sitting steady at 12.2 volts and just about 8 amps, 7.8 amps, which is really good. And it's a lot better balanced than I thought it was going to be. So yeah, the good Lord definitely been looking after us on this one. Okay, she's all done. Got her all wired up. These are going to be our output wires here. Alright, we got this wound up here. Just giving it a test run, seeing how it's going to work. And we're pulling about 8 amps. I expected it to be pulling more than that. 8 amps is pretty good. Maybe it's just finally wearing its way in here, so you might see that current go up just a little bit. I'm actually expecting it to go up at least a half of an amp. But other than that, she's looking pretty good though. I mean, she's spinning good, she's balanced pretty good. I might have to change this brush system there. Looks like the voltage is running away on us a little bit here. She ran up to about 14 volts, and then she'll kick back. Let's see when she kicks back. Yeah, so she's dropping down to 10. So we do have a little bit of a power fluctuation, so maybe that's why I got such a good deal on this device. But this DC power supply is still better than anything I could have come up with. So I mean, money well spent anyways, even if it does have a few glitches. But other than that, you know, she's looking pretty good. That voltage drop right down there. Drop right down to about 10 volts. So it could be a cap in there that's having some trouble, but let these brushes wear in and see how they're going to sit. Looks like this one here is finally wore pretty straight. And this one here is wearing pretty straight. It's a little bit wobbly, but hope we don't wreck it. Looks like it could be twisted a bit, but could probably put another well, I guess once it wears down it should be pretty good. We did put another elastic on the other side. I just kind of got some tension on there with some elastics. At least get that circumference of that commutator on there at least a little bit better than what it was, because the brushes came off of a device that were just a little bit bigger, like an eighth of an inch diameter bigger. So it's gonna take a while for those brushes to wear in. Other than that, it's looks like she's rolling pretty good for the most part. I mean, this is just a trial run, so just kind of seeing how everything lines up. Might have to go with a better brush system than what we got, but we'll deal with it one at a time here. See how these get wore in pretty good. You can already see that the lines on them are getting a little bit wider on them. They're the wear lines. So once they wear in, I think they'll be just fine. To get this into the car, we got 12 volts there. It'll be 12 volts, no fluctuations. It'll be pretty good. I am going to try just one more test. I disconnected the blower motor from driving the unit, and I'm just going to hook up our primary and see what we get for current draw on that, and see what she lines up as. Just without it spinning. So it's sitting at 12.3, and she's using 1.5 amps. That's just about right. Very good, very good. I'm very happy with what we've seen here today. That's it for now. Next time we see this, it'll probably be in the car. We'll test it in the car from there. Bye-bye.